Okay, now it's recording. Okay. So that is hypothesis, yeah? And then how and what do you use to test your hypothesis? So it means that once we set the hypothesis, so we have when we do the experiments, when we analyze our data, we have to test our hypothesis in order to make a conclusion. Yeah? Because remember, when we set the hypothesis, normally we would have two hypotheses. So when we say we want to test our hypothesis, we want to actually make a conclusion at the end. Which hypothesis between the two will be accepted or concluded? Okay. So how and what do you use to test your hypothesis? So it's back to the sample data. So we have to refer to the sample in order to evaluate our hypothesis that we will use to conclude the population. So the process of testing the hypothesis is called hypothesis testing. It's a process of evaluating the hypothesis. And it's not just about, I mean, it actually it carries a series of steps. Yeah, so a series of steps that will bring us to the conclusion or to the decision. Yeah. The goal of hypothesis testing is to determine if a specified treatment affects a sample. Experiment. All right, so types of hypotheses. So as I said, there are two types of hypotheses, the general types. So it's called null hypothesis and alternative hypothesis. So now this one is the symbol is H naught. So the superscript, the subscript O is called naught. It's actually this one, naught, which means something that denotes the initial, or something that denotes the initial condition. So H naught. So I would say H naught. So you have to know that I'm referring to this null hypothesis. And the second type of hypothesis is alternative hypothesis, which we denote as H1, H1, or sometimes HA. Yeah, both are correct. Okay, so these are the two types of hypothesis. So the null hypothesis, the nature of it is always a hypothesis of no difference. Means that whenever we let's say we want to do an experiment, right? So we are expecting that there will be a change, something happen in the experiment. So that's why we do the experiment. So our hypothesis, the general hypothesis, we would say that for the null hypothesis, there is no change. Yeah. And for the alternative hypothesis, we believe that there is something happen, and what kind of things happen, it depends on your work. Maybe there is a change in the ethanol production, for example. There is a change in the growth of the maybe the inhibition diameter, something like that. It depends on your work or your experiment. So that is the types of hypothesis. So whenever you set the null hypothesis in any of statistical tests, make sure that you are setting the right statement lah. So because I noticed that some of you switch. If you say that alternative, there is no difference of maybe the two samples, which is actually wrong. The null hypothesis always say that there is no difference, there is no change. no difference, no change, or nothing happened actually. Nothing happened. Okay, so that's the nature of null hypothesis. Whereas alternative is the opposite. Okay. Yeah, alternative is the opposite. So if let's say you are comparing the two samples, yeah. So you want to say that mu1, null hypothesis would say mu1, the mean of one, sample 1 is always equal to the mean of sample 2. Means that this is also means there is no change. No change, no difference between the two samples. If you are comparing only one sample with a standard value, maybe it is mentioned in the problem that you want to test whether the sample has, whether the mean of the sample is similar or not with maybe the standard value of anything. Let's say the mean of 12, maybe. So you want to say, I mean, your null hypothesis, you would say that the mu of 1 is equal to, okay, 12 is an example only, yeah? So means there's no change. There is no change or difference between the sample, the mean sample with a standard value. Okay, something like that. So for the two samples just now, you can also write in this way. Mu1 minus mu2 is equal to 0. Or if you are involving more than two samples, you can also put in this way. It depends on the cases that you are analyzing. Okay, whereas for the alternative hypothesis, it is opposite. Yeah. So this one, you can see the symbol is not equal to 0. Or you move it to the other side, mu1 is not equal to mu2. Yeah, unlike, it's opposite to this one, right? Or if let's say some specification is mentioned in the problem, you might want to consider this symbol. Okay, so this will be discussed in the next lecture. So there is a change, there is a difference, there is a relationship of the things that you are analyzing. That defines alternative hypothesis. Okay, so you go through yourself these examples just to check your understanding on how to set the hypothesis. Okay, let's have a look at the first example on here. A researcher would like to know if the bacteria copy numbers are different comparing media A and B after 12-hour dose. Okay, so that is the situation given to you. So means you have A and you have B. So that's the two samples. And your parameter here is the average bacteria copy number. The average bacteria copy number of A and average bacteria copy number of B. So those are the things that you want to compare. Remember, we are comparing. So how you want to set the hypothesis for this case? So remember, you have two samples. So means for the null hypothesis, let's say mu is mean, right? Average is always mu. Yeah, mu of bacteria copy number A so because we know that the null has no difference, is equal to mu bacteria copy number B. Okay, or you can also express it in words. There is no difference between the average bacteria copy number of media A and media B. Okay. So that is null hypothesis. So alternative hypothesis. So you just copy the bottom here. So in this case, it's not equal, isn't it? So it's opposite. There is a difference. There is a variation. There is a difference between the two average values. or in other words, you can express in words the average bacterial copy number for media A is not equal to media B. So in a case where you have no further extra information, you just say not equal. But if let's say it is mentioned in the question that you want to test whether it is A is bigger than B, so you have to use that information. Yeah, let's say this one is bigger than B. So it depends on the problem. Okay, and the same thing you can try to do by yourself for the other two questions. So that's how you develop the hypothesis. Okay. So errors in hypothesis testing, this is just extra information. Okay. So sometimes we make errors. For example, if let's say there are two types of errors defined here. For example, if let's say the reality, the null hypothesis is true, but we reject the null, or we make mistakes. So that kind of error is called type 1 error. And the other one is type 2 error, when the reality is the null is false, but you accept it. Things like that. This is just some concepts that you have to accept. Okay, steps in hypothesis testing. So this is what I meant by the mind map tadi tu. So one sample and two samples. So these are the division. Sample, two samples. So we are concerned with this one first, one sample. So there are two sub conditions: known standard deviation of the population, unknown standard deviation of the population. So how to know whether it's known or unknown? Is the value is given or not given in the question. So let's have a look at the general steps first. So what are the steps when we say hypothesis testing? See, this term, we want to test our hypothesis. So the steps, the first step is always to define, to specify the hypothesis, the null and the alternative hypothesis. This is what we have done just now. The second step is to choose the significance level, whether it's a 0.05 or 0.01. That's the two common values used in statistics. Again, what is significant level is actually an allowance for error. Okay, meaning to say that our data is not 100% correct. Let's say it's 0.05. So means we allow 5% for error, for something that errors that we cannot avoid. So because no data is perfect. There's no perfect data. So that is actually the meaning of it. But in statistics, we call it significance level. So 0.05 or 0.01. And we denote it as alpha. This is the symbol for it, alpha. Right? So this one, if let's say it's given in the question, you just use the value. But if it is not given, you have to mention the alpha, assume alpha is 0.05, for example. Okay. So that's the second step. The third step is to compute sample statistics. Okay, so this one, it depends on whether the standard deviation of the population is known or unknown. Or unknown. Okay, so how to differentiate that? For the first case, when the standard deviation is known. So here the rule is to use Z test, standard deviation of the population. Is known. This one is. So this one you use Z. This one is we use T. So the formula is this one. This is the formula that we have used before in previous topic. So what we have to do, let's say the first case, when the standard deviation of the population is known, but before that, before that. So this one is step number 3, where we compute the sample statistics. Means that later I'll show we actually compute the Z and T values. And what we have to do with those values, we proceed with step 4, where we refer to this rule of thumb. Call it like the rules that we have to refer when making a decision. So this one is a condition that you have to remember. So what we have to do with the Z and T values, that these things are calculated Z or T values. Besides that, we also have to find the Z or T values from table, from Z or T table. And these values, we call them as tabulated values. Tabulated. Yeah. This one is tabulated values. So what we have to do with the tabulated values, we compare with the computed Z or T and make a decision based on this thing. Okay, so if let's say, and please remember, don't forget this symbol. This symbol. What does it mean? We exclude or we ignore the negative values. Yeah. So we only take the absolute value. So if let's say the absolute value of the Z computed is less than Z tabulated, so we conclude H naught, yeah, or the other way around, or if it's bigger. So that is the decision rule. So this is the method 1. Okay, if you see here, alternatively means like another method. So means you don't have to do these two methods at the same time. You just choose. So this one, write in your notes. This one is method number 2. Method number 2. But you can use only one method. One method only. So if you have compared the Z computed and Z tabulated, does it you have make decision here? Then you just jump to the conclusion. I prefer method 1 because I think it's much it's not confusing for me to check for or to compare the computed and tabulated Z or T values. Yeah, because if you I notice if when students use method 2, they would then confuse again with the P, the alpha. So I would suggest use this one. Recommended. Okay, method 1. So once you make a decision, here is making a decision whether you accept or conclude H naught. Final step is when you state the conclusion. So means that you have to write back. If let's say, you have to conclude. So if let's say you accept null, then refer back to the problem. So if let's say the problem says that there is no difference between the mean of school A, school B, so you refer specifically. You state the conclusions specifically. So that is the final step. Okay, so that is the general step. So let's have a look at the first case when the standard deviation of the population is known, where we have to use the Z test. So how's the problem will look like? Let's say this is the problem. Suppose the mean score of all 12-year-old children on an UPSR subject were 7 and the population standard deviation is 2. So you can see that it is mentioned clearly that this is the information. So definitely you should use the Z test. And what else? Okay, let's go through the question first. If researchers were interested in whether 12-year-old children with extra tuition had a different mean score on the UPSR subject at alpha 0.05 significant level, the sample mean score taken from 16 children is 8.1. Okay, how to understand and how to digest this information? Okay, now we are talking about you can see here, mean score of 12-year USR subject was 7. What does this mean? So you have to you have to visualize population and sample. Okay, so if you see here, the last statement, the sample mean score taken from 16 children. So you imagine that in a population, you take a sample consisting of n equal to 16. So that is actually the sample. This is a sample, and this is the population, right? And that's how you match the information. The sample mean score. So the mean here is 8.1. Okay, this is referring to the sample, isn't it? This is the sample. So this is the information of the sample. Okay, so what are the information for the population? So when we talk about the mean score of all, see, all 12-year children. So this one is referring to the population. And the mean here is 7. This information. Standard deviation is 2. Yeah. So that's how you match the information. What else? Alpha 0.05. Okay. Researchers were interested in whether to test whether 12-year-old children with extra tuition had a different mean score on the UPSR subject at alpha 0.05. Okay, so that is the problem. Yeah. So means now how we want to set the hypothesis. Okay, now basically this one you can see that there is only one sample. So we know that it's one sample, one population. Yeah, and you know that the standard deviation of the population is known. So that is the category of the situation. Okay, so the mean, the alternative, and the null hypothesis you want to set. You want to actually compare the sample with the population. Means that now your hypothesis now saying that the mean of 12-year-old children with extra tuition, that's the focus, with tuition, with extra tuition, the mean is equal or not to the 7, to the population. Different means that you are referring your standard of comparison is the population. So it's equal to 7 or not. Sorry. What I mean here is like for the null hypothesis, there is no difference between that sample with the population, and the value given here is 7. Okay. Whereas for the alternative hypothesis, the mean of this one is not equal to 7. Okay. That's how you set the hypothesis. So the reason why it's important for you to digest the information, like how I assign here, what is the sample, what is the population data, is for you to set the hypothesis as well. Okay. All right. So that is the hypothesis. You can also use the symbol like the mu tuition is equal to 7. The mu is 7. The second step is alpha, isn't it? So it's given 0.05, so you don't have to worry about it. So this one is done. This one is done. The third step is to compute the mean. Okay, the step good. Compute sample statistics. Okay, now, what are the things that you need to compute? So the mean is given. This is a sample. the mean of sample. So what you have to calculate or to compute is the Z, this one. Remember this formula? So this is the one that you have to substitute here. This one is referring to the population need, which is 7. And okay, now what does this mean? This one is referring to the standard deviation of is the standard deviation of the sample actually. Yeah, so that's why the symbol is X bar. So how to know that? You are given the standard deviation of the population, which is 2, isn't it? Yeah, 2. So you have to use this formula. Okay. Standard deviation of the sample. Remember, this one is actually referring to the sample. Is equal to the standard deviation divided by the square root of n. N is the sample size, which is 16 in this case. Yeah. So you get the value here is 0.5. So this is the one that you substitute here, right? So you got the Z value of 2. Yeah. So this is the Z calculated or computed. Okay, you're not done yet. So the next thing is you have to find what is the Z tabulated or the Z value from the tables. So how you want to, what are the information that you can use to find the tabulated Z? Okay, so remember the alpha is 0.05, okay, given, or if you have to set, you have to define your alpha. So to sketch the Z, like the Z distribution, the normal distribution, sorry, and you know that the alpha 0.05 is divided into 2 if you are referring to the total situation. Okay, so each of this is 0.025, isn't it? 0.025. Okay, so if you refer to the Z table, so 0.025, in order to find the Z value that corresponds to this, you have to, the whole area here is 0.5, isn't it? 0.5 minus 0.025 is equal to 0.7. 0.5 minus 0.025 is 0.475. 0.475, that's the area of this. Okay, why you have to find that? You have to find the Z there. So if you want to refer to the Z table for the normal need, so you have to find the area again, the area enclosed by the region. So 0.475. Yeah, it's this one, right? So it refers to the value of 1.996. 1.96. Because this one is here. So 1.96. So that is the Z value, the tabulated Z. So that's how you got this 1.96. Okay. So 0.975 is when you consider the two. Actually, but if you refer to the table, you have to refer to the 0.475. Yeah? So that is the Z tabulated. Okay, this is the Z tabulated. So what you have to do with these two Z values, Z calculated and Z tabulated, you have to compare and you have to refer to this rule. So this is the rules given in this test. So if the Z, so remember this, since there's no negative value, so you don't have to worry about it. So the Z computed is bigger than the Z tabulated, isn't it? So it falls under this rule or this decision, yeah? Whereby you have to conclude the alternative hypothesis. Okay, that is your decision. So we're not done yet. Okay, so this is meant by the second method just now. So I don't like to refer to this method. This is alternative method only. So it's not compulsory. Once you have calculated Z, tabulated Z, you have calculated the Z, yeah, you have calculated Z and you have the Z tabulated. So that's it. You are done. Yeah. So this one you can skip. Huh? I don't want to explain that. Decision. Okay. So once you have the decision, you can conclude. Yeah? So you conclude means that you accept alternative hypothesis. Okay, go back to your alternative hypothesis. What does your alternative hypothesis says? It says that the mean of the students with the tuition is not equal to 7, right? So that is what you have to write. This one is 5. It's not equal to. It's not equal to the population mean, which is 7. Yeah? Or 7. So this is the conclusion. Okay. So that's how you solve a problem with one sample when the standard deviation of the population is known or is given. Okay. So let me summarize back the steps. Set the hypothesis, set the significance level or alpha. Third step is to compute the statistics. So what are the things that you have to compute? You have to compute the Z value, right, based on the information given, right? And first, in order to calculate the Z, you need this sample standard deviation to use this formula. And then you substitute the values into that. We got the Z value. That is the calculated Z. The second thing that you have to look for is the tabulated Z. So how to find the tabulated Z is based on the alpha value. So since your alpha here is 0.05, you draw the Z, the standard distribution. You are looking for the area. You divide the area, the 0.05 into 2, you got this 0.025. So you have to find the area enclosed by the Z value here. So in order to find this Z value, you have to first find the area from the origin, which is 0.475. So how you get it? 0.5 minus 0.025. Where you get the 0.5, you understand that that one is your own information. It's not given in the question. So you have to remember by yourself that half of the area of the standard curve is 0.5. Okay, total is 1. So you got 0.475. You refer to the standard table, get 1.96, the Z value. So that is tabulated Z, tabulated Z value. So what you have to do with the two values, you compare. So our situation is the second situation where you have to conclude the alternative hypothesis. Okay, so this one is, if you want to refer that also can, but I would suggest this group, please skip this one, because this one is already in the lecture notes. Lecture note is from the course coordinator, so I cannot erase it. Otherwise, if you compare your notes with your friends, then you ask me why you don't have this thing. But this is just the alternative method. Okay. So once you have compared the Z value, the Z computed, Z tabulated, you can straight away go to the conclusion. Conclusion, since you accept the alternative, so go back to your alternative hypothesis that you have defined in the first step. So you have to state specifically. So if let's say you just conclude accept alternative hypothesis and that's the end of your answer, you would lose marks over here. Because for the conclusion, normally the marks is 2. Yeah? The mark is 2. And the relevance of it, why we really, why we emphasize this step is because in reality, if let's say you do the experiment, and if let's say you just conclude at the end of your experiment, or you want to tell people that at the end, the conclusion is to accept null hypothesis. But what is your null hypothesis, isn't it? So you have to tell again the people what is your hypothesis, because It's only you who do the experiment who knows the hypothesis. So the public should be informed again the specific details of the hypothesis. Because when we talk about hypothesis testing, it's just for the sake of, for the sake of reaching which conclusion. But at the end, you have to state your conclusion specifically. Okay, so that is actually to train you to be ready with the research letter. Yeah? Okay, so this is the steps that I have going through. Okay, this is just a summary of it. Okay, so if we refer to the elite just now, yeah, so this is what I have covered. When standard deviation of population is known. So the steps are similar, yeah? Hypothesis, compute, and all this stuff, yeah? So it's not different thing, yeah? So this is just for you to be clear lah. Okay, the second situation, I just continue without break because I want to finish things earlier. So the second situation is when the standard deviation of the population is unknown, when it is not given. So we don't use Z test anymore, but we use T test. Yeah, so that's the difference. And what kind of other things that you have to also calculate is this one. You have to use this formula. And where this formula comes from is from LU1. Is the basic formula for this one is actually variance, but we know that variance and standard deviation is related. So you can find S from here when you find the square root of S2. Okay, so basically this is the formula that you have to use. And once you solve for the S, then you can actually use here. Okay, so I'll show later. Okay, if you see, let's go through the general steps. So there is a similarity with the previous test. The only difference is in the middle. So like, for example, the first step to state the hypothesis is the same. Second step to choose the significant level is also the same. The third step is to compute the statistics. So this is where it differs. Instead of Z, you have to calculate the T. You also have to find the T from the tabulated T, compare the two T values, make the decision. This one is similar, and finally make a conclusion that is also similar. So the difference is only in the middle in terms of the T computation. Okay. Yeah, so let's go to this example. Suppose a researcher wished to test whether the mean score of fifth graders on a test of reading achievement in his or her city differed from the national mean of 76. So you see this one is the bench, the values that you have to refer to. Okay, so it's given 76. The researcher randomly sampled the scores of 20 students. The scores are as below and assumed to be approximate normally distributed. Okay, don't get confused with this statement. This is not an indicator that you have to use the Z test. You have that one is because if you talk about T distribution, it's also normal distribution, but it's not necessarily Z. Yeah? Okay, so what kind of information that we can digest from here? So means that you are taking a sample of this sample of N20. So these are the data. Yeah, only that. That's the the mean here just now. The mean, the national mean. So here national is referring to the national, like we're talking about the country, Malaysia, and so you can relate it with the population. population. That's how you relate it. So the mean here is 76, the population mean. Okay. And you can see that there is no information on standard deviation, isn't it? It's unknown. So that's how you know that it is unknown. Standard deviation of the population. And alpha is also not given. So by alpha, you can set it, let's say you set as 0.05. But you have to mention somewhere in your workout. So that is the basis of your calculation. Okay, so that's the information that you have. So from here, you know that it's one sample. Standard deviation of the population is unknown. So you would know that you have to use the t-test. Okay, what else? So how to solve this? So the first step is to set the hypothesis. So since our reference is 76, the mean, right? So that will be your basis for your hypothesis. Means when you talk about the mean of a sample, actually, this one is referring to the sample, mean of sample. So your hypothesis, you would say that for the null hypothesis is equal to 76, or there is no change with the national score, so national mean. If you want to write in sentence, no change, no different. Whereas for the alternative, there is a change, or there is a, it's not equal to 76. Okay. So second step is to choose the level. So assume that 0.05, or you can choose also 0.01. It's up to you, since it's not given in the question. The third step is to compute the, not just the mean actually, is to compute the statistics. When we say statistics, it covers a few things that you have to compute. One of them is mean. And also you have to compute other stuff like the t, the s, and so on. So first is mean. So how to calculate the mean of the sample is just add up, divided by 20. So 72 plus 69 plus 98 until 74. Divide by 20, you get this mean. That's straightforward. But not just the mean that you have to calculate, you also have to calculate this one, isn't it? Because the formula is this. So you have to have the information of the standard error of the sample. This one is a standard error, or the estimation of the standard deviation of the sample. So another word is, or another term is standard error. So how you want to find that? So you have to use this formula, and you need to find the s first. The s first. So how to find the s? So you have to refer to this formula, this one. Okay, so how to use this formula? So here, for this problem, the n is 20, remember? So that's fine. But what does this mean? These two means. So you have calculated the x bar just now, right? For this one, for this problem, which is 80.85 x bar. So the x symbol here, let me copy this equation. So s squared is equal to 1 over n minus 1 square root of x minus x bar squared. Okay, that is the formula. So how you want to use this formula? N is 20. 20 is because of the sample size. Yeah. So you can write 20 minus 1 is 19. So this is the big bracket that you have to calculate. It's a bit tedious actually, but how you want to refer to this? X here is referring to the each of the values over here. For example, 72 is the okay, 72 minus x bar is the average, 80.85 square, right? And don't forget this symbol. It means that the summation. So you have to add the next one, which is 69, isn't it? 69 minus 80.85 square plus until the last point. So that's why I said it's a bit tedious. Until 74, you have to be a bit careful when calculate this because it involves lots of figures. 80.85 square. Okay, and don't forget the big bracket. Yeah. So the summation of all the things inside multiplied by 1 over 19. That's give you s squared, not s yet, s squared. So s, you have to find the square root of s squared. Then we get the s. Yeah. And that is the value that we have to substitute into this one, right? Okay, and you solve for the standard error of, or the standard deviation of the sample, this one. Okay, this one has been solved for you. So that is the value. Okay, why you need that value? Because you want to find, this is t calculated or t computed. Okay, so x bar, which is this one. Okay, 80.85 minus 76 is the value of the population. 76 given in the question. 76, and this one is the value here. So you get t calculated. This is t calculated. So the next step is to find tabulated t, or from the table. So how you want to find the t from the table? So you have to refer to the t table, t distribution. So what kind of information that you need from for the t distribution? Okay, let's have a look at the t table. It looks a bit similar to normal distribution, but with different information that we have to look for it. So it has alpha, which is the upper tail area, not the alpha, the one given, the one that you set 0.05 tau. So this one you have to a bit careful. And also you have to know what's the degree of freedom. Degree of freedom is given by the formula n minus 1. So n is the sample size, which is just now 20. Yeah, so your degree of freedom is 20 minus 1, it's 90. Okay, so go back to the, okay, okay, just now, the tail area, so how to find the tail area? The tail area is referring to only one side, which means 0.05 divided by 2, that's give you 0.025. Okay, that is the tail area that you have to refer for your t table. Okay, so if you refer here, this is 0.025, and you go for 19, isn't it? 19. So the value is over here. That is the t. The values inside here is the t tabulated. Okay, 2.093. Go back here. So this is the value. Yeah, this is t tabulated. That's how you find the t tabulated. And what you have to do with the t tabulated and t computed just now, you compare based on these rules. Yeah, these rules. So your t calculated is 2.44, whereas for the t tabulated is 2.093. So the calculated is greater than the tabulated, so it falls under the second situation. Yeah? Right. So you have to conclude H1, or the alternative hypothesis. Okay, so again, this one is alternative method. Don't do that if you refer to the first one. So this is just skip. Yeah. So write in your notes. I don't have it. I don't write it like directly in the notes, but you just jot down. Okay, so once you conclude H1 or the alternative hypothesis, so you have to make a conclusion. Make a conclusion. Okay, so go back to your hypothesis now. What your hypothesis is? If you want to put it in words, the mean score of the fifth graders of the test is not equal to the national mean, which is 76. Yeah? So that's, yeah, it's different. See? It's different from the population mean. So you put in proper sentence. And to be better, you put like at alpha, actually at alpha at the beginning of the conclusion at alpha 0.05. It can be concluded that the mean reading achievement score is different from the population. Okay, so that is when the mean of the population is unknown. Okay, so this is again the summary. Set the hypothesis, set the alpha, and then compute the things that you have to compute: the mean of the sample, the standard deviation of the sample, find the t, find the calculated t, find the tabulated t, and compare the two t values according to this rule. Okay, and finally make a conclusion. Yeah. This is another example. Let's go through this before we finish the class. The average life of TV tubes is 1,200 hours. The standard deviation is known to be 300 hours. Okay, obviously you know this one is use Z test lah, because this one is known. A new process is introduced, and 100 tubes produced by this process have a mean life of 1 to 65 hours. So this is referring to the sample. This is like it's a sub thing inside that. Test the claim that the new process is better, assuming the standard deviation is unchanged. Okay, so how you want to, what kind of things that you are comparing? You want to compare with the average life, with the standard values. So that's why if you see the hypothesis, you are referring to that value, not 1 to 65. So the mean is the null says that it is equal to 1,200. Alternative is not equal. Okay, so that's why it's important for you to understand the problem first. Identify which one is actually referring to the population values. Okay, 0.05, is it given in the question? No, so you have to choose by yourself. And then what else? Yeah, so this one is referring to the mean of sample. You have to compute the statistics. So since this one is standard deviation is known, you have to use Z. So you have to use the Z formula. So you have to find the Z calculated. Yeah, Z calculated. So first find this one. Okay, so it's given to you 300 from the question. So this one just substitute, got this one, this value, Z calculated. Find, tabulate the Z. Right, so how you want to tabulate the Z? Since your alpha is 0.05 just now, so here is 0.025. We divide by 2, yeah? Because you just need one. In order to find the Z here, you just need the one side only. So this one is referring to 1.96. How to know that? You refer to the Z table. And then when you compare the two values, 1.96 and 2.17, the calculator is bigger, right? So you conclude H alternative, sorry. So this one is the alternative method. So this one is alternative method. Don't ask me again how to do this. I'm not going to discuss this method. This is alternative. So you can skip it because you already use the first method to compare the set. So once you compare, you conclude #1. Right? So means the conclusion is that at alpha 0.05, okay, there is evidence that the new process, does it mention, is better? So since the question says here is better, so you can also use this one. This one also can, but this one is more specific. This one is more specific because it's referring to the question. Better means in this life is more than 1,200 lah. The average life means that it's longer kan. Average life, we talk about the jangka hayat kan. So that's why you have to understand the problem. So means that jangka hayat yang lagi panjang is better lah. So that's how you relate with this. That's why it's greater. Okay, so when you go back to the conclusion just now, what is it? So is the new process is better. So that's the conclusion. Okay, the next example you go through by yourself. It's the same thing, but this one I think is a T, because the standard deviation is not norm. Okay, so you can see it's very, you know how it looks like, the division, so it's actually not that really difficult. So you can see the difference is only on the computation of the statistical values, the T on the side. Okay, so that's what today's lecture is all about. So first we talk about what is hypothesis, different types of hypothesis, alternative, null hypothesis, and then errors in hypothesis testing. And the main part is the hypothesis testing. And here we talk only about one sample. And there are two situations: known standard deviation of the population, unknown standard deviation of the population. And each of that has its own steps. Okay. This is just a summary. So if you refer back to the ellipse just now, we refer the top part of this mind map when for the one sample population. So in the recorded lectures for next week, since next week is the public holiday, so I would just post the recorded lecture. So it will cover the two samples, two populations, which is the bottom part. Okay, so that will be lecture 6 and 7. So today's lecture is lecture 5, if you refer to the ellipse. Okay, so that's what today's lecture is all about. So I share back the attendance.